So we will look at several aspects of the difficulties of quantifying the impacts of climate change. Obviously, the most important one is valuing what are called non-market goods. We'll see what we mean by that. Okay. So ideally, one would like to get an estimate of the damage each ton of CO2 does or some other greenhouse gas does after it's been emitted by whatever activity that is involved, like land use change, just production, travel, and so on. Why do we worry about additional ton? Because CO2 is always there in the atmosphere. It's a part of the atmospheric constitution, and obviously whatever emission we are making is an additional ton, and we want to be estimating the impact of that additional ton we put in. So CO2 has a long residence time, so it's hard to estimate the cost. We already said several times in previous chapters that CO2 can stick around for centuries, if not millennia. And how do you estimate the cost? This year, this decade, it's not very easy. It's also well mixed, so even if you emit it here, it's going to be mixed around the globe pretty quickly. So the impacts are global and not local. So that means even if you reduce the emission here, others will benefit from it. So that also plays into the motivation or the cost-benefit analysis of reducing CO2 as well. Impacts on many sectors like health, agriculture, cognitive abilities, productivity, crime, conflict, morbidity, mortality, and so on and so forth. So there is a vast array of impacts which are indirectly or directly related to CO2, because CO2 is often associated with pollution like particulate matters, especially PM2.5, which causes serious COPD, right, and so on. And then there are more complicated things like non-market goods, like clean air. How do you value clean air? How do you put a value on it? Biodiversity, even more difficult, especially because biodiversity is intuitively obvious, but it's not even so easy to quantify what biodiversity is. And the value of species that go extinct. So if you just look at the number of species that have gone extinct since the 1500s, including fishes, reptiles, birds, mammals, and amphibians, there are two issues. One, you have to detect the signal that species have gone extinction. Oftentimes we are finding them after 100 years because nature makes the rules and biology finds the loopholes. So even when we think a species has gone extinct, it may have managed to survive somewhere, but obviously we reduce the numbers by a lot. Just because you found it doesn't mean it is thriving, right? So let's say you go to a forest and you have 10 tigers instead of 500 tigers, right? So it's not gone extinct, but there is a cost. There is a loss of biodiversity. Okay, so detection is important, then attribution. How do we know humans caused or our emissions caused that extinction or the reduction in number? That's complicated as well. Nonetheless, whatever it is, how do you put a value on that? How do we say that, sorry, I didn't put it into display here. Maybe I should do that again, but it's okay. I'll see how it came out and then redo it. Okay, so putting a value on non-market goods is not easy. So declines in species survival just since the 1980s. Corals, obviously, you know, ecotourism. Who doesn't want to dive in the Great Barrier Reef or the Andaman Seas and so on, right? So some have done better in this direction. Some have gone worse. Mammals staying relatively flat. Birds, many have gone extinct. Amphibians are suffering. Cicads, kind of plants, they have been suffering as well. Okay, so the estimating the value of non-market goods. There are a couple of ways. Just asking people, how much do you pay for restoring a coral? They would, or how much would you value a coral that's along the coast close to you? Usually people give an estimate, but that's usually high because they're not asked to pay for it. They're just asked to think and say, how much value would you put on it? Okay, and then there is another one called travel cost method, where you ask people how much would you spend to go visit that coral. Okay, that is a real commitment, saying I wouldn't mind spending so much to go and visit it. That means you put that much value on it just to go and see it. Okay, so there are additional things like what are called tipping points or extreme events, as this author refers to, like the loss of the West Antarctic ice sheet or the thermohaline circulation in the ocean, which is responsible for the mild climate over Europe compared to the same latitudes over North America, and so on. How do you put values on those? Okay, so usually it is done by asking many experts. We will see some estimates of this sort, and you try to get a sense of where the numbers are, and also think about things like cost of protecting against sea level rise. This gets complicated because let's say a Navy, let's say US Navy is told that the Norfolk base is under grave danger from sea level rise. Navy is not going to wait to see if this is true or not. Navy wants to be ready for any eventuality, so it's going to plan. But how much sea level rise can it really plan for? That's going to be determined by how much it costs, what their budget is. They cannot necessarily protect against 2 meters sea level rise, even if that's what the projection says, but the cost of doing that ends up being beyond their budget. Right? That's where economy comes in again as well. Okay, so this lab, which the author is also involved, called the Climate Impact Lab, actually puts up data and information on measuring the real world costs of climate change, which is very useful. So despite the uncertainties, that provides a resource for how it is done, how it can be done, and how it can be used for driving action and policies to motivate action, incentivize action, and reduce incentives to just wait and see. Okay,